Hello, today we're going to be looking at a special case of problems, and that is when an object is in free fall, you know that its acceleration is going to equal gravity, which is 9.80 meters per second squared. And that is if there's no wind resistance or anything like that, the object doesn't have wings. So we're going to very frequently deal with idealized situations, and we'll just use gravity as 9.8. Now, contrary to what this picture might show, I've never actually been skydiving. I know I did a pretty good job of photoshopping my face in there, but that is actually not me. So let's say I were to drop a 1 kilogram and a 5 kilogram hunk of lead, and they were to hit the ground or fall and hit the ground, which would hit the ground first. They would both hit the ground at the same time because gravity accelerates all objects at 9.8 meters per second squared, regardless of their mass. And we'll explore why when we talk about gravity a little bit deeper later on. Do heavy objects and light objects really fall at the same rate? Well, in the real world, there is some air, and there is air, and that can affect some objects pronouncedly, like a tissue paper. This is normally when I take something heavy like or dense, fairly dense like a marker, and something like a piece of paper, and I show you that they fall at the same time. Well, they don't if I just drop them, but if I crumble up the paper and drop the marker and the paper at the same time, then they will hit at the same time. Once you remove air resistance, things really do fall at the same rate. And it's a pretty good approximation for a lot of things. Not all things. Airplanes don't fall at 9.8 meters per second squared, because if they did, the airfare would be really, really cheap, I think, because no one would want to fly. So gravity is 9.8 meters per second squared. Should that be a positive or negative number? That's a good question. Well, gravity accelerates things down. So if we call down negative, which frequently we'll do, then the acceleration number will be minus 9.8. If we call down positive, which we might want to in some cases, then the acceleration number will be positive 9.8. And again, this number g that I'm giving you, this is the symbol for it, is lowercase g, but really it just gets plugged into the a number, your acceleration number, into the equations. So if you drop an object from rest, what the acceleration means is that gravity changes its velocity by 9.8 meters per second every second. So if we drop it from rest, after 1 second, it's going to be falling downward at minus 9.8 meters per second squared. Gravity changes its velocity by minus 9.8 meters per second per second. That's where the meter per second squared come in. And then after another second, it'll change by another 9.8, so minus 19.6, and then minus 29.4. And then after t seconds, it'll be falling at minus 9.8 times whatever time is, times t, and then that'll be its velocity in meters per second. If I were to graph this, it would look about like this. And if I were to ask you to interpret this motion diagram or this motion graph, well, we've got velocity, we've got an object that looks like it starts from rest, and then it falls in the backwards or downward direction, and it's increasing in velocity. Now, what if I asked you what's the initial acceleration when it's dropped from rest? Did I trick you? The answer is not 0. The answer is still minus 9.8, because that's the acceleration. As soon as it's released, that's its acceleration. So again, just to throw a picture at this, how fast is the rock? If I drop a rock after 1 second, it's moving at 9.8 down. After 2 seconds, 19.6 down, etc., etc. Now these velocities that I've got next to the falling rock, are these average velocities or instantaneous velocities? Those are instantaneous velocities. That's the velocity it's traveling at 1 second. Okay, at 2 seconds, it's falling at that velocity. So these are instantaneous. Now, if I were to ask you how far, now what I'm going to do is I'm going to round 9.8 to 10 just to make the math easier when we look at this. So instead of 9.8, it's falling at 10. Instead of 19.6, we're saying rounding it to 20. So just to make the math a little bit easier. So how far did the rock fall during the first second of free fall? Well, if we want to figure out how far it's going to fall, we need to know the average velocity. Well, the initial was 0 and the final was 10, so that means the average was 5. So 5 meters per second for 1 second, it traveled 5 meters. Now if we look in the next second, okay, the initial velocity is 10, the final velocity is 20, so the average is 15 meters per second, and it did that for 1 second, so it would travel 15 meters. Okay, in the second, it's going to travel, again for the same reasons, 25 meters. And then in the third to fourth second, in the third second, it's going to fall 35 meters. So that's wanting to show you that each second the object falls a greater distance. So it falls 5 meters in the first second, a greater distance, and then a greater distance, and then a greater distance. If I were to graph this on a displacement versus time graph, we would have a line that is curved downward. The fact that it's curved downward tells us that it's moving backwards or down. The fact that it's curved tells us that the velocity is changing. And what's happening to the velocity according to this? The fact that it's getting steeper tells us that it's speeding up. So it's moving backwards or down and speeding up. Okay, so there's three main types of problems that you can look at when you're dealing with gravity. Starting from rest, which is the easiest, which means that our initial velocity is 0. That makes things easy. You can throw an object downward or you can throw an object upward. Probably the most challenging is throwing an object upward, but these aren't too bad. So if I drop an object from rest, what is its velocity after 2.5 seconds, and how far has it fallen? Well, there's always going to be a couple different ways you can solve these, and I'll show you one. I'll show you one example, and then maybe mention a different example. So, very frequently when you're working problems, I haven't really stressed this, but very frequently it's helpful to draw a picture. If I was working these problems on the board, you would very frequently see me draw a picture. I probably do draw a picture on. Well, I don't think I've been too good about that on my written problems. I probably should. That's just because if I work a little bit more of a challenging problem, then I will draw a picture. I just got a little bit lazy, I suppose. So in this case, we're going to call down positive because it's only going to go down. It's not going to go up and then down. So we're gonna say down is positive. So let's see. What do we know? We know it was dropped from rest, so v1 equals 0. We know time is 2.5 seconds. We're looking for its final velocity, and we know the acceleration is equal to 9.8 meters per second squared. Now, should I make acceleration my acceleration number positive or negative? Well, I've established that I'm calling down positive, so I'm going to make the acceleration due to gravity positive because gravity is down. So next we need to pick an equation, and the equation we're going to use is v2 equals v1 plus at. Okay, plugging in our numbers, we get v2 equals 24 meters per second. Now, if I want to know how far it's traveled, okay, I would use the initial and the final velocity after 2.5 seconds. So the initial velocity is 0, the final velocity at 2.5 seconds is 24. So you need to figure out the average velocity first, which would be 12 in this case, 0 plus 24 over 2. And now we use the very first equation we got, which is the velocity equals displacement over time. So notice that I've used delta y instead of delta x in this equation because it's falling down. I will not penalize you if you use delta x on a vertical problem on the test. So just to let you know. So multiplying the average velocity times time gives us about 30 meters. Be the displacement. The other way I could have used this, I could have done this is I could have used this equation delta y equals v1t plus at squared over 2, because I have v1 is 0, so this goes away. I've got the acceleration as 9.8, and then time is 2.5, so I could have solved it that way. By the way, if you had called down negative, that had been perfectly adequate, appropriate in this case. It really would be fine. I just chose to call down positive, but if you called it negative, we're good to go. Okay. Let's see. So we drop a rock from rest, and it lands 6 meters. So this is a very, very tall person. They're over 18 feet tall apparently, and so they drop it and from rest. How fast is it moving when it hits the ground? So I'm going to call it's simply going down. If it was going up and then back down, I might call up positive, but because it's simply going down, I'm going to call down positive again, just to show you that you can use down as positive. So we know the initial velocity is 0. We're looking for the final velocity. We know the displacement is 6 meters. Now again, the displacement is down, so the displacement is positive because I've said down is positive. And the acceleration is also positive because I've said down is positive. So what we want to do is pick the equation, and the equation that we want to choose is this guy. V2 squared equals V1 squared plus 2a delta y. Now I've got the delta y exploded into y2 minus y1, but realize this is really just delta y. So plugging in the numbers, looking for V2, I don't know why I've got a VF there, but we get that the final velocity is positive 11 meters per second. Now again, this equation doesn't necessarily yield the right direction on your final velocity, but since I just dropped it, I know it's going to be going down. Okay. A little trick that you can use, I'm going to skip this one, is if you want to figure out how high you are above the ground. Let's say that you're on a bridge and you want to see about how high you are above the water. All you have to do is count Mississippis, count seconds, and then do this little physics trick. So if I want to figure out my displacement, how high I am above the water, I'm going to drop it from rest. So that tells me my initial velocity is 0. We're going to round gravity to 10, and we're going to leave that t squared as t squared. So what I'm going to do is go and simplify this, and you get delta y equals 5 times squared, and that's it. So if it takes about 2 seconds for a rock to hit the ground, your time is equal to 2. So 2 squared is 4 times 5 would be 20 meters. So you'd be about 20 meters off the ground, or about 60 feet. So that's just a little trick that you guys can do if you want to see how elevated you are. And now it won't let me, now I can draw plenty. Okay, next to throwing an object downward. These are just special cases, but you can use the same basic approach to all of these. They're the same five equations that we're going to be using. So if we throw an object down or simply drop an object down, the thing is I'm usually going to call down positive. Okay, so let's throw an object down at 6.4 meters per second from a height of 34 meters. How fast is it going when it hits the ground? So things that I know. Well, for one, I know the initial velocity. The initial velocity is not 0. It is one thing I know is that the initial velocity is not 0 here. I throw it downward at 6.4 meters per second from a height of 34 meters. So things that I know is that the initial velocity, I'm going to call down positive, and it's moving downwards initially. So the V1 is going to equal 6.4. The displacement, it's going to fall down 34 meters. So my delta y, or if you want to call it delta x if it makes you feel better, is also going to be positive 34 meters. How fast is it moving when it hits the ground? So we're looking for V2, and we want to we also know that the acceleration is due to gravity, so the acceleration is 9.8 meters per second squared, which again is down, and I called down positive, so those are both going to be positive. So this would be the equation that you would use in this case, and this would be your answer. Okay, throwing an object upwards, that gets there's a little bit more to this, but not too terribly much. So in general, when I throw an object upward, I'm going to consider up to be positive and down to be negative, just to be, that's probably what I would recommend doing in all cases when this happens. So if I throw a rock upwards at 30 meters per second, and I round gravity to 10, okay, gravity is going to change its velocity by about 10 meters per second every second. So it's going to be traveling up, then after 1 second, it's going to be traveling at 20 meters per second. And then after another second, it's going to slow down to 10 meters per second. And then after another second, it's going to be traveling at 0 meters per second. And then it's going to come back down traveling at 10 meters per second down, and then 20 meters per second down, and then 30 meters per second down here. So a couple things that are important to note here is that, for one, what do you know about it at the highest point? Okay. At the highest point that it reaches, its velocity is 0. That's important. You need to know that. Another thing that's important to know is anytime it's at the same elevation, the velocity is the same. So it left my hand at 30 meters per second, and when it comes back down, it's also moving at 30 meters per second, just in the downward direction. The same here, 20 meters per second. Anytime since it's at the same elevation, it's also 20 meters per second, just down. So those are important things to notice. Okay. Now, a question I might ask you here on a test, if I ask you a multiple choice question, what's the velocity of an object at the highest point? The velocity of an object, of a projectile thrown upwards at the highest point, is 0. What is the acceleration at the highest point? Not 0. The acceleration is 9.8 meters per second squared down. So don't let me trick you on that. Okay. All right. Let's see. So the speed at the highest point is 0. The speed when it reaches the ground, again, is the same as when it left. And the time it takes to go up and come back down. If it comes back to the same elevation, the time it takes to go up is 3 seconds in this case, and it's going to take 3 seconds to fall back down. So you would know that if it took 3 seconds to go to reach the highest point, it would be in the air for twice that, or 6 seconds. That's another thing that's important to know. Okay. So if I throw a rock upwards at 64 meters per second, how long does it take to reach the highest point? How long after the ground does it take to reach my hand again? How long after it reaches the highest point does it take to get to my hand? Okay, so I worked all that out here. So in letter A, since we're looking for it at the highest point, we know that our final velocity is 0. That's the very top. We're given the initial velocity, 64 meters per second. Okay, and again, I'm considering up positive and down negative on these problems when you throw an object upwards. That's what I would recommend doing. So gravity is negative in this case, so it's important that you have that negative sign. And we're looking for the time. So we use our equation V2 equals V1 plus AT and solve for the time. That gives me 6.5 seconds. So it takes 6.5 seconds to go up. B is just saying it's going to take 6.5 seconds to come back down. C is what's the total time in the air? Well, 6.5 up, 6.5 down is 13 all the way around. Okay. D, we're looking at how high it went. So what we want to do is figure out our average velocity on the way upwards. So the average velocity between 0 and 3.5 seconds is 32 meters per second. And then we use our V bar equals delta y over t equation. Now, it's important when you use this equation that you have to be using the average velocity. That's why we calculated the average velocity first. And we get that the displacement equals 208 meters. E, it's going to hit the ground at the same speed as when it left. And F, this one was a little bit more involved. So what it's asking is how far is it moving when it is 35 meters below where it started. So here it was off of a cliff. We threw it up and then back down. So we know our initial velocity is 64 meters per second up. Our displacement is 35 meters down because it's below where it started, so that's why it's negative. Our acceleration is negative 9.8, and the signs of those are important. And V2 is what we're looking for. So we're going to use our last equation, and we'll get that our answer is V2 equals 69 meters per second. Now note that this gives me a positive answer, but the velocity really would be downward, so it would be negative for all intents and purposes. One other problem I want to work here is, okay, so we throw a rock upwards at 29 meters per second. So it's going upwards, so I'm going to consider up to be positive and down to be negative. What time is it 2 meters above my hand? Well, let's list out what we know. We know V1 equals positive 29 meters per second. We know time. No, time is what we're looking for. If you can hear me growling, time is equal to question mark. We know displacement, delta y, is positive 2 meters because it's above my hand. And the other thing we know, like always, is gravity is equal to 9.8 meters per second squared. Now, should that be positive or negative in this case? Well, I've considered up to be positive, so gravity is going to end up being negative. So what equation is gonna help us to figure this out? Well, I'm pretty sure this is where I left off. I forgot to unpause it again, so I finished this off without going through the whole thing. All right. So this last one that I want to work is a little bit quirky. So we're going to throw a rock upwards at 29 meters per second. At what time is it 2 meters above your hand? I'm not going to bother trying to draw because it messes up every time I do it. So we know that V1 is equal to 29 meters per second. Now we're throwing it upwards, so I'm going to consider upward positive. So that V1 is going to be positive 29 meters per second. The time is the question mark. The displacement is 2 meters above my hand. So should I make the displacement positive or negative? Okay, since the displacement is upwards, it's above my hand, that should be positive. And the other thing we know is gravity is equal to, the acceleration is equal to 9.8 meters per second squared. Now, should that be positive or negative? The acceleration is down and we considered up positive, so gravity is going to be negative in this case. Anytime you consider up to be positive, gravity is going to be negative. So we're going to use this equation, and subbing in the numbers, we get something that looks like this. Now this equation form should look familiar. You've got something times a squared, something times the variable, and then a constant. That is the quadratic formula form, isn't it? ax squared plus bx plus c. You can use the same quadratic formula in physics as you do in math, believe it or not. So plugging in for a, b, and c, we get two answers, because you will get two answers because of that plus or minus thing. You get 0.069 and 5.8 seconds. Which one is correct? Which one should you believe? Well, the answer is they're both correct. Because you hit the ball upwards, it reaches 2 meters at 0.069 seconds while it's traveling up. Then it reaches the top and comes back down, and then it's at 5.8 seconds later, now it's at the same elevation. So both are correct. One is on the way up and one is on the way down. And that is that. That is it for this unit. So you can finish up the packet. I'm available on my office hours if you have any questions.